Hello, this is Dr. Hanaa Assil, and this is about chemical bonding. So we're going to be talking about ionic bonds and covalent bonds. This is for the IGCSE chemistry syllabus. So let's take a look at the periodic table. You know that the periodic table is a table of elements, and some of them are metals, some of them are non-metals. Now, where are the metals and where are the non-metals? You should know that the ones on the left of the periodic table, so that is group 1, 2, and 3, and there are some exceptions in the middle. These are all metals. Now, the ones on the right are non-metals. And when we talk about bonding, what we're trying to do is we're trying to do something that makes the atom have a full outer shell. You know that only group 0 in the periodic table has a full outer shell. Now, all other atoms or all other elements are trying to have a full outer shell. So metals are in group 1 with 1 electron in their outermost shell, group 2, 2 electrons in their outermost shell, group 3, 3 electrons in their outermost shell. All of these are metals. They don't want these electrons in the outer shell. They want to lose them, because if they lose this 1 or 2 electron in the outermost shell, then they will have a complete inner shell. Now, groups 4, 5, 6, and 7 have 4, 5, 6, and 7 electrons in their outer shell. They want to either gain or share electrons in order to have a full outer shell of 8 electrons in the outer shell. So, the main idea is the atom wants to lose or gain what? An atom can lose or gain electrons. So, if we're looking at something in group 1, like sodium. Sodium has 1 electron in its outermost shell. It doesn't want it, so it needs to lose that outermost electron. You know that originally an atom has equal numbers of what? An atom has equal numbers of protons and electrons. So if we say that sodium is in group 1, its atomic number is 11. That means it has 11 protons and 11 electrons. The protons are positive, the electrons are negatively charged. So if I have equal number of positive and negative, the overall is 0. So the sodium atom originally has no charge. It is neutral. But if it loses that outermost electron, now it has 1 proton more than the electron. So instead of having 11 electrons, it now has 10 electrons. So it has 1 extra positive charge. So when an atom loses electrons, it becomes positively charged. Now, non-metals we said, like group 7, have 7 electrons in their outermost shell. They just need to gain 1. So originally fluorine, for example, has 9 positive protons, 9 negative electrons. So the fluorine atom is neutral. But when this fluorine atom gains an electron, now it has 1 extra electron. That means 1 extra negative charge. So it becomes a negatively charged ion. The idea is, if we have a metal and a non-metal, the metal wants to lose in order to have a full outer shell, the non-metal needs to gain in order to have a full outer shell, and the bond that is formed between the positive and negative ions is what we call an ionic bond. But if we have only non-metals, all of them are non-metals, oxygen, hydrogen, chlorine, all of these are non-metals, they're not going to lose or gain, they're going to share electrons, and this is called a covalent bond. So, ionic bonds, we said, are formed if I have a metal and a non-metal. The metal loses electrons and becomes positive. the non-metal gains electrons and becomes negative, and the ionic bond is the attraction forces between the positive and negative ions. So if he says what is meant by ionic bond, don't say it's the bond between metal and non-metal. That's not what we call ionic bond. The ionic bond is after they have lost and gained, and now they have positive and negative ions. The ionic bond is the strong electrostatic attraction forces between the positive and negative ions. You know that if we have oppositely charged particles, they attract. This is called an electrostatic attraction force. So the ionic bond is the attraction between the positive and negative ions. You will be required to draw dot and cross diagrams. So let us try and draw dot and cross diagrams for, so we'll start with ionic compounds. So if I say we need to draw dot and cross diagrams of lithium fluoride, the first thing we do is look at the periodic table. Where is lithium and what is fluoride? You should realize that fluoride is actually fluorine. So if it is standing alone, it is called fluorine. But if it is bonded to something else, it is called something fluoride. So basically, we're looking at lithium and fluorine. In order to draw the dot and cross diagrams, the first thing we do is write the symbols of each one. So I have lithium, Li, fluorine, F. Then I look again at the periodic table. How many electrons in the outer shell of each? You can see that lithium is in group 1, so it has 1 electron in its outermost shell. Fluorine is in group 7. It has 7 electrons in its outermost shell. So the lithium wants to lose that outer electron and become positively charged ion. The fluorine now has the 7 outermost electrons plus the electron from the lithium. So we're going to denote the fluorine electrons by dots and the electron that we got from lithium by an X. Now the fluorine has an extra electron. That means it has an extra negative charge. Please note that sometimes he specifies the notation. He tells you, for example, fluorine has to be a dot and lithium, the electron from lithium has to be an X, or he leaves it for you to decide. So either way, one of them is a dot and the other is an X. Please do not forget the charges. The lithium now has a positive charge and it has lost its outer electron. Fluorine has the 7 outer electrons plus the one it got from lithium, so it has an extra negative charge. So this is my dot and cross diagram for lithium fluoride. Let's try again. Let's try to draw dot and cross diagram for magnesium oxide. Again, what's the first thing we should do? Look at the periodic table. Where is magnesium and where is what? Oxide is oxygen. So magnesium and oxygen. We first write the symbols, Mg and O. And then we look again at the periodic table. How many electrons in the outer shell of magnesium and how many electrons in the outer shell of oxygen? I'm going to remind you again that the number of the group is the number of electrons in outer shell. So magnesium is in group 2. It has 2 electrons in outer shell. Oxygen is in group 6. It has 6 electrons in outer shell. And then we decide what does each atom want to do. Magnesium has 2 electrons in its outer shell. It doesn't want it. It wants to lose it. So we're going to lose the magnesium and make positive. Now, how many positives? The magnesium is going to lose 2 electrons. That means it has 2 extra positive charges. Oxygen. Oxygen has 6 of its own. It needs 2 more. So we're going to give it the 2 that we got from magnesium. And that means it now has extra 2 negative charges. This is either written -2 or 2-. It doesn't make a difference. So this is my dot and cross diagram for magnesium oxide. The magnesium now has 2 positive charges. Do not forget the charges. The oxygen has 6 of its own plus the 2 it got from magnesium. That means it has 2 extra negative charges. Okay, let's try to draw dot and cross for barium chloride. What is barium chloride? We look for at the periodic table. We're looking for barium. Please remember there's something called barium, and there's something called bromine, and there's something called boron, and there's something called beryllium. So anyway, barium is in group 2, chlorine is in group 7, so we're going to write the symbols. Then we look, barium is in group 2, that means it has 2 electrons in its outermost shell. Chlorine has 7 electrons in its outermost shell, so it needs how many? The barium has 2 in its outer shell, it has to lose 2. But the chlorine can gain only 1. So what am I going to do with the other electron? I will get another chlorine atom to donate the other electron, and that means for each barium that has lost 2 electrons and becomes 2 positives, I need 2 chlorines. Each of them have their 7 plus 1 from the barium, and they have each an extra negative charge. So this is my dot and cross diagram for barium chloride. Please sit down and practice drawing the dot and cross diagrams. Okay, let's try to draw sodium oxide. Again, looking at the periodic table, where is sodium and where is oxygen? Write the symbols. Then, how many electrons in the outer shell of each? Sodium has 1 electron in its outer shell, it needs to lose it. Oxygen has how many? It has 6, so it needs how many? You do know that a shell is full if it has 8, of course. Okay, so oxygen has 6. To be full, it needs 2 more. But the sodium can give me only 1. And that means I need 2 sodium atoms to give me 2 electrons to give to the oxygen. Each sodium has lost 1 electron, so it now has an extra positive charge. The oxygen has the 6 of its own plus the 2 that it got from the 2 sodium atoms. So this is the dot and cross diagram for sodium oxide. Are we following? Okay, let's try a question. Which statement describes the bonding in sodium chloride? Again, we're going to think, is sodium chloride what? It's metal and non-metal. That means we're talking about ionic bond. And we said, what is the ionic bond? It is strong force of attraction between oppositely charged ions. Can you see that that's our answer? Okay, let's try this one. Which 2 elements react together to form ionic compound? We said to form ionic, I have to react what with what? I have to react a metal with a non-metal. A metal can have 1 or 2 or 3 electrons in its outer shell. So R is not a metal, T is not a metal. So X, I can have X, 1 electron in its outer shell, and then I need a non-metal that has 4 or 5 or 6 or 7. I cannot use 8. Why can't I use T for a compound? T has a full outer shell. It's a noble gas. Noble gases do not need to lose or gain or share electrons. They already have a full outer shell, so they will not form compounds. So, which of these will form an ionic compound? I want X with a non-metal, so I can have X with Z. X has 1 electron in its outermost shell, so it's a metal. Z has 7 electrons outermost shell, so it is a non-metal. When they react together, they form an ionic compound. Try to draw dot and cross diagram for lithium nitride. What do we mean by nitride? You should realize that anything with a D, oxide, fluoride, nitride, this is the one, the periodic table. So nitride just means nitrogen. So I need lithium with nitrogen. You should realize nitrogen is in group 5. That means it needs 3 electrons, but each lithium can give me only 1 electron in order to have a full outer shell, which is the inner shell that has 2. And that means I need 3 of the lithium. Each of them have a positive charge. I can write the 3 down, or I can write it next to the lithium. So I have 3 of the lithium, Li+, and I have the nitrogen, 5 of its own, plus the 3 it's going to get from the 3 lithiums, and that means it has an overall extra 3 negative charges. Okay, so that was ionic. What about covalent? We said covalent is if I have 2 nonmetals. And if we have 2 nonmetals, then they're not going to lose or gain, they're going to share. And that means I don't have any positives or negatives. They're going to share electrons. So 2 atoms sharing a pair of electrons. That means 1 electron from each atom, and we're going to share them. So the covalent bond is the attraction forces between what and what? The electrons that are being shared, which are the bonding pair of electrons or the shared pair of electrons, and the positive nuclei of each atom. Remember that these atoms have a positive nucleus because it has positive protons. There is a strong attraction force between the pair of electrons that are being shared, which are negatively charged, and the positive nucleus of the atoms, and this is what we refer to as the covalent bond. So please don't say the covalent bond is a bond between 2 nonmetals. No. The covalent bond is the strong attraction forces between the bonding pair of electrons and the positive nuclei of the atoms. So, how do we draw dot and cross diagrams for covalent compounds? Like hydrogen molecule. If I say hydrogen molecule, that means I have hydrogen atoms. Now, each hydrogen atom has 1 electron. How many electrons does it need? Remember that this is the first shell. The first shell is full if it has how many electrons? 2. So all I need is I need to share a pair of electrons with another hydrogen atom, so that when we share these 2 electrons, now these 2 electrons belong to each of them, so each of them has a full outer shell. So we're sharing, no losing, no gaining, no positive, no negative. They're sharing the pair of electrons. And remember that in this case, you can draw it with circles or without circles, whichever is okay for you. We can draw it either way. And remember that if I'm sharing a pair of electrons, this is called a covalent bond. So this, when I'm sharing 1 pair of electrons, this is a single covalent bond. Okay. Let's try drawing dot and cross diagram for a chlorine molecule. What is a chlorine molecule? It is made up of chlorine atoms. Now, each chlorine atom has 7 electrons in its outer shell. Remember, for all of these, what we care about is the number of electrons in outer shell. So, chlorine has 7 electrons in its outer shell. How many does it need to have a full outer shell? Remember, we need to have 8, so in order to have 8, I need 1 more. So these 2 chlorines are going to share 1 pair of electrons. Each of them is going to donate an electron. That means now each of them has 8 electrons, so it has a full outer shell. So we're sharing 1 pair of electrons. Do not forget that we still have the rest of the 7. We had 7, we're going to share 1 of them, and these other 6 are somewhere around the atom, not involved in the sharing. And again, we can draw it with circles or without circles, and that is the dot and cross for chlorine. What about water? Water is a molecule made up of oxygen and hydrogen. Now, let's take a look. Each hydrogen has 1 electron and needs another 1. But the oxygen has how many electrons in its outer shell? If you look at the periodic table, it's in group 6. So it has 6 electrons in its outer shell. So actually the oxygen needs 2 more. But each hydrogen can give me 1. So I need to share with 2 hydrogens. So for each of these, I'm going to have a pair of electrons between the oxygen and the hydrogen. 1 from the oxygen, 1 from the hydrogen. Do not forget, the oxygen had 6. It is using up only 2 to be shared with the hydrogen, so it still has the rest of the 6. It still has 4 electrons somewhere away from the sharing. Don't put them between oxygen and hydrogen. Anything between the atoms means it is being shared. So either, again, we draw them with circles or without circles. Both are correct. Can you see that? Okay. Let's try dot and cross diagram of something called methane. If you haven't done organic chemistry yet, I'm telling you that methane is something that has 1 carbon and 4 hydrogen. So it's made up of carbon atoms and hydrogen atoms. Now, we said each hydrogen has 1 and needs 1. But each carbon in its outer shell has how many? It has 4, so it actually needs 4 more. And that means it will need 4 hydrogens to share 4 pairs of electrons in order to have a full outer shell. So this is the dot and cross diagram for methane. Again, with circles or without circles. What about ammonia? Ammonia is between nitrogen and hydrogen. We're going to say again, hydrogen has 1 and needs 1, but the nitrogen has how many? The nitrogen is in group 5. It has 5 electrons in its outer shell. That means it needs 3. So it's going to bond with 3 hydrogens, each of them sharing a pair of electrons with the nitrogen. Remember, the nitrogen had 5. It used up only 3 for sharing. It still has 2 electrons somewhere away from sharing. Do not put them between the nitrogen and the hydrogen, with circles or without circles. Please practice this. It's very important. Hydrogen chloride. What is hydrogen chloride? This is hydrogen with chlorine. The hydrogen needs 1, so it's going to share a pair of electrons with the chlorine, and the chlorine had 7, it needs 1, so they're sharing 1 pair of electrons between the hydrogen and the chlorine. Are we better in dot and cross diagrams now? Okay, so when we said if we're sharing 1 pair of electrons, this is called a single covalent bond. What if I'm doing oxygen molecule? Oxygen has 6 electrons. How many does it need from the next one? It has 6, so it needs 2. So they're going to share 2 pairs of electrons. Each of them is going to give 2 to the other one. So they're sharing 2 pairs of electrons. Each of them had 6, so we still have the rest of the 6 somewhere away from the sharing. And that means in an oxygen molecule, we're sharing 2 pairs of electrons. 2 pairs of electrons are called a double covalent bond. So if we have 2 nitrogen atoms, each nitrogen has 5 electrons in its outer shell, how many does it need? It needs 3, so the 2 nitrogen atoms are going to share 3 pairs of electrons. Each of them still has an extra 2 electrons that is not involved in sharing. So nitrogen molecule, the atoms are sharing 3 pairs of electrons. This is called a triple covalent bond. What about carbon dioxide? Let's try and draw the dot and cross diagram of carbon dioxide. Carbon dioxide means I have carbon and oxygen. So each oxygen, the oxygen has 6, so it needs how many? It needs 2, so it's going to share 2 pairs with the carbon. What about the carbon? The carbon had 4 of its own. It needs another 4. So it took 2 from one oxygen. Now it needs to take another 2 from another oxygen. So this is the dot and cross diagram. Do not forget that each oxygen still has 4 electrons in its outer shell that is not involved in bonding. That means that each carbon and oxygen has a double covalent bond. That means the carbon dioxide has two double covalent bonds. What about ethene? Ethene again is a molecule we'll be talking about when we talk about organic chemistry, but for now we know that ethene has two carbons and four hydrogens. So this is what we're starting with. Two carbons, four hydrogens. Now, how are we going to distribute electrons? Of course, each hydrogen has one and needs one from the carbon. So these are the hydrogens. What about the carbon? We said the carbon, each of them has four and it needs four. It's going to take two from the two hydrogens, and that means it's going to take two from the neighboring carbon. And that means between the two carbons, I'm sharing a pair of electrons, and then we have the I'm sharing two pairs of electrons between the two carbons plus the pair of electrons with each hydrogen. Methanol. What about methanol? Again, we're saying methanol for now is carbon with three hydrogens around it, and then an oxygen, and then a hydrogen. So how are we going to distribute electrons? Again, each hydrogen has one and needs one from the carbon. What about the carbon? The carbon has four and it needs four. It already took three from the hydrogen, so it's going to share one with the oxygen. Take note of the notations. So if you're going to give carbons the X's, hydrogen the filled out dots, then we can give oxygen either empty circles, or I can put an X with a circle so that I can draw it like this. Please note that we have three different elements. Each element has a different notation. The oxygen is going to share one pair with carbon, one pair with hydrogen, and it still has four electrons not involved in bonding. Let's look at this question. A covalent molecule contains a total of 4 shared electrons. Please note that sometimes he tells you 4 pairs of shared electrons or 4 electrons. So here he's saying 4 electrons. If he says 4 pairs, that means they're sharing a total of 8. So we're looking for something that has a total of 4 electrons being shared. So let's take a look at each of them. What is ammonia? This is ammonia. How many electrons are being shared? We have 2, 4, 6. We have 6 electrons are being shared between the nitrogen and the 3 hydrogens. He wants something that has 4. What about HCl? HCl, we're sharing 2 electrons between the hydrogen and the chlorine. Methane, we're sharing how many? 2, 4, 6, 8. We're sharing 8 electrons between the carbons and the 4 hydrogens. What about water? Water is sharing with 2 hydrogens, each one a pair of electrons, so I have a total of 4 electrons being shared between the oxygen and the 2 hydrogens. What about this one? He's saying which diagram represents the outer shell electron arrangement in a nitrogen molecule. Remember what a nitrogen molecule looked like? We said nitrogen, each atom needs 3, so we're going to share 3 pairs of electrons between the 2 nitrogen atoms, and each nitrogen has extra 2 electrons that we have not used for sharing, so of course my answer is D. What about this one? Complete the dot and cross to show the electron arrangement in a molecule of ethanol. You know that each hydrogen has 1 and needs 1. So we're going to give it 1, and we're going to take 1 from whatever is next to it, carbon or oxygen. The carbon needs a total of 4. It took 3 from hydrogen, so we're sharing 2 electrons between the 2 hydrogens. Now, what about the oxygen? The oxygen has 6 and needs 2. So it's going to share 1 pair with the carbon, 1 pair with the hydrogen, and it still has 4 extra electrons not involved in the share. Can you see how we draw these things? Okay, what about this one? Silicon tetrafluoride. Silicon is in group 4, just like carbon. So it has 4 electrons, so it needs to share a pair of electrons with the fluorine. But don't forget that each fluorine has 7 in its outermost shell. So after you have written the X and dot between each silicon and fluorine, you still have 6 electrons around each of the fluorines. Do not forget them. What about this one? Chlorine forms a covalent oxide called chlorine oxide, Cl2O. How do you think we should draw the dot and cross diagram for Cl2O? That means we have oxygen in the middle, a chlorine on either side, and they're sharing 1 pair of electrons, each chlorine with the oxygen. Don't forget the extra electrons, the other 6 electrons around each chlorine, and the other 4 electrons around the oxygen. Are we okay with dot and cross diagrams? Okay, let's compare between ionic compounds and covalent compounds. You should know, first of all, that ionic compounds, like sodium chloride, which is salt, these dissolve in water. So ionic compounds dissolve in water. Covalent compounds do not dissolve in water, so they dissolve in what we call organic solvents, like ethanol. So covalent compounds will not dissolve in water, they will dissolve in ethanol or other organic solvents. Another thing is ionic compounds conduct electricity, but they conduct electricity only when molten or in solution. They will not conduct electricity as a solid. So sodium chloride as a solid will not conduct electricity. When molten, that means I heat it until it melts, or in solution, that means I dissolve it in water, then it will conduct electricity, because when it is molten or in solution, the positive and negative ions are free to move, and that's what we need to conduct electricity. They do not conduct electricity when solid, because when solid, the ions are not free to move. Please learn these explanations. What about covalent compounds? We say covalent compounds do not conduct electricity at all. The only covalent compound that conducts electricity is graphite, and we'll be talking about that. But in general, covalent compounds do not conduct electricity because they don't have any free ions. So this is due to the absence of free ions or free electrons. Remember that for something to conduct electricity, it has to have either free ions or free electrons. Ionic compounds, when molten or solution, have free ions. A metal, for example, when we talk about metals, we'll say they conduct electricity because they have free electrons. Now, covalent compounds don't have either of that. Okay, another thing is ionic compounds have high melting and boiling points. This is because of the structure. If we talk about the structure of ionic compounds, we're going to say the structure is in the form of a crystal lattice. The crystal lattice is a giant 3-dimensional structure with alternating positive and negative ions. So I don't have just one sodium next to one chlorine. I have a 3-dimensional structure with many positive, negative, alternating positive and negative ions. And that means that we have strong attraction forces between all of these positive and negative ions in the giant crystal lattice, which is what we call the structure. And all of this needs high temperature or a lot of energy to break them and separate the ions. While covalent compounds have low melting point. Now, if we say why do they have low melting point, we say because they have weak attraction forces between the molecules. For the compound to melt, I'm just trying to separate the molecules. Molecules have weak attraction forces between them that need a small amount of energy to be broken. What if I'm comparing two ionic compounds? We already decided that ionic compounds should have high melting and boiling point. Now, which one will be higher, magnesium oxide or sodium fluoride, for example? Magnesium oxide, each ion has 2 positives and 2 negatives. So there is strong attraction forces between the increased charges. While Na plus F minus, for example, they have just 1 positive with 1 negative. So the increased charges on the magnesium oxide means there is stronger attraction forces between the ions, and that needs more energy to be broken. So something like magnesium oxide will have higher melting point than sodium fluoride or sodium chloride and so on. So what is this? Which substance is ionic? Do you understand the meaning of volatility? Volatility, if something is volatile, that means it evaporates easily. That means it has low melting point. So would you expect ionic compounds to be volatile or not volatile? We said ionic compounds have high melting and boiling point, so they're not volatile. So they have low volatility, they're not volatile. Would they conduct electricity when molten? Yes, we said good ionic compounds would conduct electricity when molten. Will they be soluble in water? Yes, we said ionic compounds are soluble in water, so my answer is C. Okay, that's the end of this, and thank you for listening, and please continue listening. We will be doing the rest of the syllabus shortly. Thank you.